welcome to Defn, episode number 36.
Are you going on live yet? Are you going on air yet?
Yeah,
mate?
we are. Screw it, we are.
You know what you're
I think
doing.
look, there is like at least, I told you, right? These two dedicated, too many fans. Exactly two.
Yeah.
So they are online now. And
Two
they want us
hardcore
to
fans.
start.
Yes,
Yeah, let's get the hardcore. They're knocking on the pub door. Let's open up,
they're eager.
Okay, clicked on broadcast, so it's going to start.
Right,
Yeah, I think
okay.
it should be on now.
Yeah.
So we
We're
are
live?
live. Yes.
We're live. Whoa!
Fantastic.
Okay, so
Sufficiently dramatic.
Oh, hold on.
now we'll...
Sorry, I just had to mute the YouTube for a second.
No, Ray, this is an anticlimax. We were all ready to go with the live.
Well, but this is what
Okay.
we were talking about, wasn't it? It's like state again. It's a
Yes.
total nightmare. The feedback loops. I mean, I got some kind of feedback on a separate state that was being recorded separately.
Uh-huh.
It's like multi-threading.
Uh-huh.
Of myself. I mean, how
So
weird
we're-
is that? That you
We're
can't make this
experiencing
shit up.
concurrency problems.
Yeah.
I think we should have our podcast recording bingo. Can you hear me? No? Oh,
Yeah.
I don't know. Are we live yet? No.
I like that idea, actually.
Check. Everything is checked.
Yeah. I mean, chaos at the beginning. That's it can't get any worse. Then that's the idea. That we kind of open up with total chaos, and then everything gradually settles down, and we get more chaotic at the end. So there's a kind of arc to the story.
Nice.
I hope.
I like it.
Yeah.
We come full circle in the end. I
Yeah,
like that
exactly,
we come
yeah.
back to chaos. I appreciate it.
Always. Yeah. Entropy is
I think it's-
our middle name.
We end on a
think it's-
cliffhanger.
I think it's even worse. I mean, we start with a lot of chaos, and then finally, when we're trying to this makes some sense. Oh, time. We're done. So we can't record anymore. So we go back to the same thing again.
Yes.
So every episode we start with this kind of bullshit, and then it goes, oh, finally we're talking about something reasonable. It's 2 hours already, so let's stop.
The beautiful solution in the margin. It just doesn't fit.
Exactly. So episode number 36 it is. Welcome to the show, Peter.
Thank you. Thank you very much for having me.
I would
It's an
like
absolute
to
pleasure.
pronounce your last name though.
Yes.
How do I Tosanis?
Oh, wow. That's very good. Yes, exactly that. How sound.
But that sounds Greek though.
That is
it
Greek.
Ah.
That is Greek.
Oh.
Yes.
So you're from Greece.
My father was from Greece, so I am officially part Greek.
Wow.
Yes.
Okay. So from that's the reason for the whole Tao and everything. Okay. Now everything is
That's all. We're already having insights at this point. No.
okay. That's
yes,
that's
part,
not right.
part of the reason for the Tao, but also other significance in the name for me. So from the mathematical constant Tao, and also
Yeah.
from Enso, with one S, sort of the Japanese concept of circle and so on. So it has some significance for me, and I like the sound of the name.
Right. Beware. It's a bit of a problem, though. I was just going to say,
Why,
there's
what?
a bit of a problem with open source from Peter now, because you should always beware of Greeks
Yes.
bearing gifts.
Yes, Greek bearing gifts, exactly. Well, I feel like there needs to be at least some hurdle. You see, you can tell if somebody really wants the library at that point because they've gone to the effort of actually figuring out how to type it in. So if they're not committed enough at that point, then so it's a good primary level filter, I'd say.
So let's get to the I think so you're from you're not from Greece, but you're originally from Greece, but right now you're in Berlin, right?
Yes.
You're,
So I was born in Johannesburg in South Africa, and I was there for many years. Then I moved to Thailand, and I was living in the north of Thailand in a city called Chiang Mai for several years, and most recently in the last year or so in Berlin. So newly in Berlin, especially in Berlin time. 1 year is not much.
So what made you move to these different places, Peter? Was it just like a itch to travel, or was it more
explore
than
the
that?
world.
So Thailand was a bit random at that time. I just sold my first company, and I wanted to travel, and I kind of picked somewhere that I'd heard good things about, but it was very, very random. I wasn't planning on actually moving there. I went there on vacation, and the intention was to kind of hop around a little bit and explore the region. But oddly enough, first place I ended up, which was in Chiang Mai, I just immediately fell in love with the place, and I was so happy and comfortable there that I didn't move again. I ended up there, and I ended up staying for 5-6 years, and and I made that my home for a while, and that was a really wonderful place, and I'd like to go back. As for the jump from Thailand to Berlin, that was a little bit more, also I'd say, spontaneous. My partner at the time was interested in coming to Berlin for her work, and I had traveled here once before briefly, and I liked the look of the place quite a bit, and I for a long time wanted to get into Europe, and there were also some let's say family things going on. I had some personal reasons as well for wanting to make a change, and at that time, again, it was more or less just jumping in with both feet and then giving it a try. So relatively spontaneous.
And are you doing closure in Berlin? Because we've been to Berlin recently as a bit of a closure hotbed. So is that kind of another small magnet for you as well? The big closure community in Berlin.
So let's say sort of is the answer to that. So definitely there is, as you put it, I think there's a bit of a hotbed of closure here. I am working in closure in Berlin, but that wasn't the primary draw. I think.
No.
I think, let's say I'm fortunate enough, and I think a lot of closure developers are, that they can kind of work remotely very often as well. I think since the market for closure developers is relatively small, generally speaking, closure roles are let's say disproportionately often remote. So most of the consulting that I did, for example, was remote. It just happened to be in this case that the city coincided with let's say the closure in this case. But like in the case of Chiang Mai, that wasn't a primary factor, let's say, bringing me here.
Right. Okay.
So how did you get into closure? Let's talk about your journey into closure.
My journey into closure, yes. So let me think. So I had, this was, I don't know, a little bit before closure version 1. So way back when most of the information was just on the Google group, and I'd finished. I think I just sold my first business, which wasn't terribly engineering related, and I started working on a project, a passion project of mine, which I've been sort of kicking around ideas for a very long time, and I knew that it was going to involve a lot of programming. And at that time, I kind of started just researching what programming tools were available at that time. I had a draw to Lisp, so I wanted to try, in particular, sort of move towards a Lisp language, or at least evaluate those. And I ended up evaluating, I think I looked quite seriously at Common Lisp at the time, and I looked at a language which Paul Graham was working on at the time called Arc, which didn't really materialize into much. And then there was this closure thing, which I had heard nothing about. At that point, I'd heard zero word of mouth about it whatsoever. It just happened to pop up when I was searching for Lisp variants. And what initially drew me was that it ran on the JVM, and I started reading, I think, some of the original information that was out there from Rich on sort of some of his views on things like state and concurrency, and some of the interesting, let's say, experience and philosophy that went into the language, and it started attracting me more and more. The more I dug into it, the more it appealed to me. And anyway, I started actually developing a prototype of the product that I was working on in Clojure, and the more I used it, the more it occurred to me that this was the right fit, and in particular that it was a really good fit for sort of prototyping. Shoot, great.
So you said you were looking for a Lisp, but what made you look for a Lisp? Why were you looking for a Lisp?
Okay, good question. So I think it's a little bit difficult to turn back. I think in general, I've been looking for an excuse to try a Lisp because I'd read much about them, and I'd read a few books on Lisp, and I'd kind of tinkered around with Lisp a little bit, but there's a very, very big difference between reading about something or kind of playing around with it in
Sure,
a toy capacity
definitely.
and actually using it in a
Yeah.
production environment. And ultimately, I just wanted, I think that the dominant factor was I just wanted to have an excuse to actually use a Lisp in production to get a feel for what that was like. And this was also at a time,
But what
let's say,
specifically about the Lisp was drawing you? I mean, because we're kind of circling around it a little bit. What
okay.
what particular aspects of Lisp or of forget Clojure for the moment, but what particular aspects of the thought around Lisp was making you think, yes, I really want to try that concept rather than Java or whatever else you were using before?
Sure. So a few things. Lisp, I think a lot of people are drawn to Lisp because of the, let's say, the air of mystery that it tends to have a little bit. I think it's very difficult to confuse the culture around Lisp with the culture around Java, let's say, right? Like Lisp is always, at least the way I perceived it, has always been seen as sort of a hacker's language. And a lot of the old, McCarthy papers and things like this, Paul Graham articles on Lisp, a lot of the materials on Lisp always spoke about Lisp with this kind of reverence, which I don't, at that time anyway, I don't take particularly literally, because people often speak about all sorts of things in very glowing terms, and I think that's one of the reasons I wanted to actually kind of get my hands dirty with it and see what it was like in practice. But there seemed to be this promise behind Lisp, right? That there was some kind of enlightenment waiting on the other side of sufficient time with Lisp, right?
XKCD style, it's a Jedi language, you know?
Exactly. And I think for many programmers, that can already be enough to kind of spark their interest, because when you're comparing it to alternatives and you see Java or you see other languages that maybe were available at the time, it appealed to me. And I liked the foundations on which it was built. Again, like the lambda calculus, things like this, the concept of macros appealed to me. And in general, philosophically, I like the concept of something like a Lisp, which is this idea that you take very basic, primitive concepts that can kind of compose in interesting ways, right? So it's not complex. I guess as a weird analogy, it's something like the game of Go, right? Where like you have a simple set of rules underneath, and from that can arise sort of organically a deep and interesting set of logical constructs. And for me, that was something that I had definitely gotten the impression that Lisp offered, and it was enough to get me to sort of dip my toe in it, as it were. And and the experience, let's say, quickly reinforced it, kind of closed the loop quite quickly, and made me understand, yes, okay, this is actually, you get what's on the box, and it is interesting and it is worthwhile. And like anything, there's pros and cons, but definitely there are some profound and important ideas here which are worth some time, and which I think, if used in the correct way with the correct understanding of the trade-offs, can be important leverage, let's say, if you're trying to get a product developed or you're trying to do something interesting.
So how did that, what were you doing before that? I mean, because you mentioned, various languages, but because I take your point that it was a kind of spiritual journey to some extent, that you were looking for the Jedi sort of, the language of the, the ancients, let's say. But also, I guess to some extent, you must have been feeling some pain, or feeling like there was something that the current languages or the current environment that we're using couldn't quite deliver. There was some unrest in your mind, which drove you to this other place.
Yes. So I think that's a good question. The answer is, I actually tend to be quite practical about these things. I think ultimately you can more or less build anything with anything, right? If you're sufficiently dedicated / stubborn. The thing maybe that was missing for me in other languages was something that is in some way not important, and is in some way really, really important, and that was joy.
Right.
So I started programming when I was really young, and I started with Borland Turbo Pascal, I think 7.0, something like that, as a blue IDE and the help file and all the rest of it. And at that time, the first time I was exposed to programming, and I kind of taught myself, and I just used to write little games and things like this, I had a particular fascination in the learning process of that once I started using programming more kind of as a in a professional capacity, that joy had kind of gone away, and I started seeing the tools and the languages more as a means to an end. And Clojure and Lisp and these things, they kind of reignited a little bit for me some of the passion that I felt the first time I was introduced to programming as a child, and the first time kind of the light went on, and I thought, wow, this is really neat. I can express ideas here in a really interesting way, and I feel like I have power, and I feel like I'm not constrained by the language. I'm constrained by my own capacity to kind of let's say push against the boundaries of what let's say what my creativity allows. And I guess that's maybe a long-winded way of saying the joy was something that was missing in a lot of the other things, and it's something that I suspect that I might find in the direction of Lisp, and I did. And ultimately, Clojure, I think, for me, offered something even more than a Lisp. Sort of Lisp was what got me in the door with Clojure. That was kind of, like I would put it, was sort of one of the things on the box that kind of attracted me. But actually, ultimately, the thing that ended up paying dividends and kept my interest in Clojure specifically over so many years was more than just that it's a Lisp, but actually some of the specific design aesthetics and semantics in the language that I think were largely a result of Rich and his particular views on things, and the way that these views have kind of been distilled into the essence of the language in a way that you can actually feel. And that sometimes, like when somebody approaches Clojure for the first time, they're often approaching it, because of the STM or because of the JVM or because it's a Lisp, things like this, right? For things that are easy to understand. But actually, the thing that for me makes the language so powerful and so elegant and so lastingly beautiful and interesting is actually a lot of the more nuanced stuff underneath. Like I say, pointing to sort of Rich's design and conceptual aesthetic, which kind of permeates the language, and those things I think are almost maybe uniquely to be had in Clojure, or at least aren't often so easily apparent in other languages. Does that kind of answer the question?
It definitely answers the question. Yes. Pretty comprehensively, I think. We can come on to like some of the more detailed stuff and some of the kind of I mean, I think you're right. We wouldn't be both here, I think, if we wouldn't all still be here if we didn't think there was some pleasure to be had by using the language, which is a kind of weird thing, because I think you're right. There is some pleasure for sure in using it, and it can be like a professional pleasure, but also a pure pleasure. And I think that's definitely unusual. I've not really felt that in other programming languages also. But there's also a few rough corners as well. Let's not be.
That'll be a nice advertisement for Clojure. Clojure gives you pleasure.
But it's actually true, though. I mean,
of course.
I guess people who are doing Haskell, when their types compile and all this kind of stuff, I think they're probably very pleased. I mean, I'm sure there's definitely some pleasure in other languages. I'm not denying that.
Yeah,
but,
that's true. I think it comes from the small surprises or some things that you thought like they were really difficult, and then you get into this new language, and then suddenly they click, and then you feel really nice. Because I think I agree with you, Ray, completely that there aren't enough languages that give you this kind of feeling. Because recently I was playing with Rust, and of course the first 3-4 chapters are exactly like C, and I was like, what the hell am I writing? This is ridiculous. And then once you get into the concurrency thing, you're like, wow, C level concurrency, and then it can catch like race conditions and everything at the compile time. There's like, this is nice. So there is just one selling point. But then again, I feel really dirty writing that kind of code without any parentheses. Now I have this buffer around me in my code. Now I feel safe and secure and nice around the Lisp now. And if I have to write in the free floating C shit, I was like, this is weird.
But look, one thing which I do want to say, which I feel kind of compelled to add, is that I think that, especially in terms of things like pleasure, right? It's inherently subjective. And
Sure.
I think in general we have a tendency in our industry for getting into this mindset that my language is better than your language, or you're using your language, therefore you're stupid, or how could you possibly be using this language? It's shit. And that's kind of a human thing. It's sort of a natural thing to do. But I think I just want to make the point that you know, like you mentioned yourself, right? Clojure itself has pros and cons from my perspective. Even when I'm using it, there's aspects of it that I'm not too happy with. But ultimately, I think the tactile feel that someone gets from a language and what they're particularly looking for from a language and what ends up stimulating that sense of joy or not, I think is ultimately subjective. And I think it's ultimately also a question of fit, right? What is the particular problem you're trying to solve, and how close is the language to that particular to that model, right? And I think in general, certain languages maybe have more of a flexibility to conform in an organic way to more different kinds of models. So some languages might be quite restricted in the sets of things in which they're well applied. But definitely there's subjectivity, and definitely there's a matter of fit. And I think ultimately what you do with the particular tools you have matter a lot more than the tools that you're using.
I think it's interesting, isn't it, that Mats, for instance, specifically designed Ruby to be pleasure, to be a programmer's joy,
Fun,
and that was his goal actually. And I think many people, you look at, I've never been to a Ruby conference, but I've seen some shows, and people seem very happy there, and I've definitely read enough blog posts where people are, very positive. And I've been to a few JavaScript conferences where people are incredibly happy with the language, So I totally agree, Peter. I mean, it's definitely very subjective, and it's not about, my language is better than yours. It's what you do with it, and you can get a lot of pleasure out of weird languages. That's for sure. Yeah. Anyway, yeah.
like brainfuck. I think as long as you're writing in brainfuck, or what is the other one called, Malbogle or something, Malbogle, something like that. Those are specifically made to give you pain. So there were a couple of languages which are specifically for the pain.
Well, some people might enjoy that too. It's not for us to judge.
People write poetry in Flemish, so.
There you go.
And in Perl.
But is that pain for the author or for the reader? I'm not sure.
I think it's like Lisp. It's an acquired taste.
Okay, good answer.
Okay, so let's get into some of because you're a prolific open source contributor, and you have so many libraries available, and especially some of them are probably used everywhere in every language maybe. So of course I don't think we have enough time to get into every of these things, but there are three particular things I think we'd like to highlight. One is Timber, of course, the logging library, and second one is Carmine. I'm really interested in your design decisions behind Carmine, because I think this is one of the first libraries where I saw, wow, macros make sense here. This is wonderfully written library, and I learned a lot by just reading your code. And then, of course, the Center, which is like the whole, the front end, back end, real-time stuff. So which one should we start with? Maybe Timber?
Shoot, as you like.
So can you give us because usually we go through different libraries, and some of the people who are listening, they're not familiar with them. So maybe if you give a quick idea about what this library is about and what is the problem that it's trying to solve, that'll be nice.
Gotcha. So Timber is a logging library for Clojure, and it is all Clojure, meaning it doesn't lean against any particular Java logging framework of any kind. So out the box, you get full-featured logging, including things like namespace filtering and logging levels, and support for different appenders and middleware and all sorts of things through pure Clojure, without interrupt with any particular Java logging or Java logging configuration in particular.
Yeah, but this is also for Clojure script, right? Because you made it using CLJX, and so any particular reason why you're still with CLJX but not moving to the official CLJC stuff?
So largely just a case of being a little bit slow to make breaking changes, right? So the motivation to switch to CLJC is not very strong. Basically, it's the motivation to switch to Clojure 1.7. And at the time, and this was some time ago, at the time, the last time I evaluated this, my general feeling was what we get in exchange for switching to Clojure 1.7 as a minimum dependency was not worth the making that a requirement on the library consumers. And in general, one of the things that I really appreciate about Clojure and that I try, usually unsuccessfully, to kind of offer in my library code is backwards compatibility when possible, and in general a sense of stability, because usually my libraries, I'm using them in production applications, and I know a lot of other people are too. And if your logging library breaks because somebody decided to improve some feature or bump some dependency, and you're just trying to get your job done or trying to make your project work, it's not a lot of fun. So in general, I think there's an economic trade-off figuring out when to do that. And at the time, last I evaluated, there wasn't a strong incentive to bump, and I polled on Twitter, and there were a number of people who were still using older versions of Clojure. So I stuck at that with CLJX. But almost certainly, it's probably about time to make the jump to CLJC. It's about time now, because I think most people have migrated to 1.7. There's 1.8. There's 1.9. Does that answer the question?
Because this is, of course. So this is one of the libraries which is...
Can I just answer one question? It was a bit confusing to me, actually, in your answer there, was about versioning. If you make a version with CLJC, I don't know what your current version is, but let's call it 8.3. You make a version 9 with CLJC. How are you going to break people? I'm a little bit confused there.
So if I switch to, let me think about this. If I switch to CLJC, if I switch to Clojure 1.7 as a minimum dependency, you're talking about making a new version of Timber?
I assume you would do.
Okay. So not breaking in the sense that people's current version is going to break, but generally speaking, I have a limited amount of time. So if I switch the sort of base, the master branch to Clojure 1.7 or whatever it is, most of the work is going there. Hotfixes is going there. My main focus is going there, which means essentially it makes the previous version end of life.
Okay.
So then I'm forced into the situation, either if important hotfixes come out, either to maintain both branches, which is not really something that I can reasonably do, because honestly, if I had that kind of time, I'd rather publish more code. So it kind of just pushes me then into a situation where either I'm leaving a branch to kind of end of life, or I'm being forced to put more time into maintaining two branches. And like I say, I've got nothing against that if there's a strong motivation to do it. And sometimes that might be the case. In this case, last time I checked, there weren't any particular benefits from switching to 1.7 for Timber, right? So people wouldn't have experienced any particular clear benefit to the upgrade there. So there wasn't a strong incentive to incur any costs at that time.
Yeah. So I was about to ask, like, because this is how did the library evolve? Because was it plainly Clojure initially, and then later you started using Clojure script?
Yep.
And the other question is basically a two-part question, obviously, and then the other question is because logging doesn't come to mind as the first thing when you're trying to do cross-platform on JVM and on JavaScript. So what kind of challenges did you face during this one?
Okay, one sec. So first question, if I understood correctly, you were asking like how the library came to be?
Yeah.
Okay. So when I started, like I mentioned, when I started using Clojure was kind of pre-Clojure 1.0 days, and at that time, I think it's possible I probably had some of the largest Clojure production applications in production. This was like way back when, and I had some large applications at that time. And I was constantly running into all sorts of little odds and ends that weren't quite working in Clojure, or like rough edges in Clojure that maybe other people hadn't encountered so much because I don't know, maybe people weren't working at that scale, or they didn't have like production applications at that point. One of the things that I ran into at that time was just logging. So obviously you can log with Java, and that's perfectly idiomatic, I think, and a lot of people actually prefer to do that. And certainly if you're working in some sort of an environment where you're going to be interrupting with Java logging anyway, that might still make sense to do. In any case, at that time, a lot of the Clojure products that I was building were pure Clojure, and developing some kind of little logging library that was just pure Clojure at that time was, like 120 lines of code for what my needs were. and it was really simple. And writing 120 lines of code was massively less effort and complexity actually than trying to figure out the mess of the Java logging stuff at that point, which I was not familiar with. So it was literally just a case of reaching for, by Rich's definition in this case, what was easier for me. It was easier for me to implement the Java log. It was easier for me to implement logging and closure than to figure out the Java logging stuff at that point.
Yeah.
And then as these things go, it kind of grew organically. And you mentioned actually, so Timber, which is on version 4, and Carmine, which is on version 3, I think both were some of the first sort of, at least their original versions were some of the first closure libraries that I've written, and they kind of grew organically as my needs grew as I was working on my own projects or for client projects. And at some point, I kind of reached out into front-end stuff or cross-platform stuff with ClojureScript, and it occurred to me that in fact most of the interesting work is inherently cross-platform. Right. So for logging on JVM or in JavaScript, you asked, like, was there a lot of effort or something? Were there a lot of differences? Well, the actual surface area for the interrupt that you're concerned with is quite small. The surface area for interrupt is basically the stuff that actually puts stuff out, right? So your appenders that are writing something. Most of the rest of it is actually inherently cross-platform, right? Because you're dealing at the compiler level, so it's stuff like elision for logging calls that you don't want to run, or it's pure closure code, right? So making the jump to JavaScript was not terribly difficult. One could argue, let's say, and I probably would argue this, that if I'd originally have had the idea from day one to actually make a cross-platform, I may have made sort of slight tweaks in the design here and there. Just to make the let's say the shared API slightly more polished for the cross-platform application. But in this case, I think it was good enough. Like I said, we kind of grew into it organically, and it served the purpose. So it
okay. So moving on to the next one. Of course, I mean, this is Carmine is a Redis client for Redis, I think. Yeah. So how did you design this thing? Can you explain, like, how it works? Because this if I understand correctly, Redis guys publish their protocol, their whole thing as a JSON file. And then you take it, and then, so I think it's better you explain it how it works actually.
So Redis is awesome. I like Redis a lot, actually. Redis is one of my favorite pieces of technology overall. And again, it's not perfect. There's trade-offs in it, like everything else. But I really, it has an important place in my heart. I'm very fond of it, and I like the author a lot. He's actually one of the programmers that I take a fair bit of inspiration from. Anyway, so I had a lot of applications where Redis was a good fit. I took a look at some of the other libraries that we had at the time. I don't actually recall very concretely, because there were several other closure Redis clients at that time. I don't actually exactly recall what the issues were. Some of them, I remember for sure, didn't work well in production. So they had issues with strange things like memory leaks because they were using the Java client underneath, or some of them would break with large payloads or under high load in general, or there were things with connection pool issues. There were minor little odds and ends that I was running into issues with. And at first I was trying to patch the problems with these other clients. And again, it just turned out at the time, my motivation was very specific. I had products that I wanted to develop as quickly as possible. And I was looking for the quickest ways to actually get to production on those products. And it happened to be, again, that sometimes trying to figure out what the issues were with the other clients and fix them in practice was taking longer than just writing something myself for the client. And so I just went sort of with the path of least resistance, which in this case was a new client. So you asked how the client works. So this is something that's quite neat. But it actually wasn't my idea originally. There was another gentleman, I can't recall his name, but it's in the commit history, and I think it's in the doc string in the namespace, who cottoned on this idea of taking the Redis JSON command list and parsing the command list And from the parsed command list, so this is for people who are not familiar. Basically, Redis has a really nicely structured API, and you can kind of see all the command documentation online. And the command documentation is populated by this JSON file, right? So there's this JSON file saying like, these are the different Redis commands, these are the number of arguments it takes, these are the optional arguments, this is the doc string, this is the version it was added into. So all of this is actually under revision control as part of the Redis project, commands.json, something like that. Anyway, so somebody with another Clojure client had this idea of basically downloading the JSON, parsing the JSON, and with that, then defining all of the public API and doing it in such a way where you actually get the benefits of the structural information. So for example, if you're in Carmine and you look at whatever, the ping command, right? And you do a doc string on ping, you get the doc string from Redis. And that's not implemented somewhere, somebody typing out, Defn, ping, whatever. It's done automatically based on the command spec. And it's a fairly simple, small application of macros, but it's a nice example of where something like a macro can be handy, because it makes the whole thing very easy to maintain. If there's a new command that's published, you just update the command JSON and you run the thing and it spits it out. In this case, the current version, it spits it out into Eden. And with the Eden, it will define all of the functions and things.
I think this is one of the neatest uses of code producing code sort of thing, like code generating code, code writing code sort of thing. Because I was looking through different libraries, and I was like, now I'm like, okay, you know what? Every database people or everybody should publish their spec like this. Then we can generate APIs so quickly, or so elegantly, not quick, but much more, there
high fidelity as well. The high fidelity.
Yeah, exactly.
Yeah.
So it's really beautiful. Okay. So
it happens that it's a good fit as well for Redis, because Redis happens to be implemented in this way where there is a very, very large API and the commands are all more or less, I don't want to say orthogonal exactly, but they're all just independently implemented like this, right? So if you were going to implement a client library for some other database, it's very likely that probably if you were doing a Clojure one, you would want to kind of fine tune the API in Clojure for some reason, right? So for example, there's an DynamoDB library as well, which isn't used very much, called Faraday, which I authored, and there's a number of tweaks on top of the underlying library because it made sense to make those kinds of tweaks for the fact that this was Clojure library. In Redis's case, it's an unusually easy and sort of natural fit for just define this function, define this function, define this function, because that's the only way that you would want to do it. It just makes sense.
Just going back originally, I mean, I know you kind of we sort of skipped over it, but you said that you really liked Redis, and I appreciate that too. I was wondering if there was something specific about Redis versus Memcache, for instance, that made you that made you think that this was special or different. What is it about Redis that inspired you?
So Redis. There's a lot that I like about Redis. Some of it is quite subjective. So some of it is just, I like the aesthetic of Redis. So what I mean by that
subjective is good, Peter. It's an opinion show. It's okay.
I'll give you both. I'll give you the subjective and I'll give you what I think is slightly more objective. So subjectively, like I say, there's just some aspects of the design philosophy that I enjoy. I like how Salvatore runs the product. I like how he does design, and I find that his manner of thinking, like Rich's manner of thinking does with Clojure, his kind of percolates through the design of the software in a way that you as a user can actually kind of tangibly feel, and that I appreciate. Objectively, I would say I really appreciate how close to the metal Redis is. So I like thinking in terms of data structures, right? And this is something that I think Clojure tends to encourage as well, is just thinking in terms of data and thinking in terms of data structures. And in general, I find one of the things that I dislike about some databases in general is it's often quite opaque, right? You send your data to the database and it's up to the database to figure out how to structure this stuff and how to index it and exactly what data structures are underneath. Maybe you know, maybe you don't, maybe it's part of a public API, maybe it isn't. But ultimately, you're leaning a lot on the database to kind of make reasonable decisions about how to store and represent and access stuff that you need. And one of the things that I like about Redis a lot, so I often use it in cases not just as so like you can use it as an alternative to Memcache, something like that. But I think that where it's more interesting is just as a data structure server, right? If you need a list, you need a list with certain specific semantics. You need a sorted set, right? It's got these really, really interesting data structures with an API that's very very transparent about the cost of operations against the particular data structures. That by itself, I think, already actually puts it in a unique position where when you want a specific data structure, and in my line of work and a lot of the stuff I've done, I often wanted a specific data structure. Nothing beat that. That was just amazing to be able to say, I want this and I want that, and I want a hash over here, and I want a sorted set, and I have very particular reasons for wanting these particular things. And it's allowed me in a lot of cases to sort of refactor, let's say, applications that were based on other databases and dramatically improve performance. Not because Redis was fast, right, which is often kind of thrown around, but because Redis allowed a conceptual remodeling of the idea in terms of the actual underlying data structures that were necessary, and that allowed sort of the algorithmic complexity to be drastically reduced. And I've had cases where, again, we had production applications that needed to be the performance needed to be improved, and just switching from this concept of kind of I'm throwing my blobs at the database and it's going to figure out how to query the stuff back to me, to look, what actual data structures do we need here, and maintaining them ourselves and taking responsibility for that, and improving performance in the system several orders of magnitude, because just having that ability to think in those terms and to be very specific about it. So that's what originally got me liking Redis. Then at some point there were some additions, including the addition of the Lua scripting in Redis. And for me, that took it to another level. Once already it was very useful. And again, in the right circumstances. I don't want to suggest it's a magic bullet for anything, but in the uses where it's a fit, Redis was very useful. Then the addition of the Lua scripting, I think, took it to another level, because it allowed, so for people who are not familiar, basically Redis allows you to build or write little Lua scripts on top of its core data structures, and actually send scripts to the client, send scripts from the client to the server and execute atomically the scripts. And this allows you to do all kinds of interesting things in a really, really performant way, in a relatively simple language, but again, really close to the metal, in a way that when it makes sense, can be awesome. And again, this often might not make sense, but in those cases where you want to be able to send something to a server and say, look, I'm sending you this thing and I want you to perform 100 operations against these different data sets, and please take an intersection of this and put it there in this map only. It is amazing. And again, I've had applications where massive amounts of logic that involved locking and all kinds of coordination between different databases and things could be dramatically simplified through the use of something like this Lua engine in Redis. And the results were just so much faster and so much cleaner and so much more tangible, because again, it gives you transparency into what's happening. So I guess for people who have, like I do, sort of an aesthetic in general, that they like to understand what's going on and kind of miss the days where you're sort of kind of doing your assembler and you know what's in your buffers and you know where your cache line is. I kind of, for languages, I feel like the value of that is in general decreasing, right? Because various reasons. It's one conversation. But in terms of data storage, I actually tend to lean more in that direction still, of liking to understand exactly how the stuff is stored. Then most recently, Redis has also introduced things like the modules feature, which now gives you kind of like a binary level way of doing some of these like extensions. And again, when it's a fit, boy, it's when that's what you want, it's great. It's unbeatable.
So do you think this is like the revenge of stored procedures? Because stored procedures kind of like were a dirty word 10 years ago, I guess. But with Oracle and a lot of the databases, because they kind of tied you into a specific language for that database. And I guess people like Datomic and as you say, Redis and other people now, as and CouchDB and MongoDB, they're all kind of back to stored procedures big time. Yeah.
So in general, this concept of dirty word, I think, is interesting. Because I think that it's something that, again, our industry, let's say, has some growing up to do. in terms of just evaluating things on a case-by-case basis. We have this tendency as an industry as a whole to say, okay, this is currently the mindset. This is what's good. Object-oriented programming is fantastic. Everything that's not object-oriented is terrible, and you're an idiot for thinking it. Or GoTo is great. No, GoTo is terrible. You shouldn't have GoTo. Functional programming is the best thing ever. If you're not using functional programming, you're stupid. And I think that...
But that is true, though.
On this podcast, yes.
Yes, on this.
I'm joking. I'm joking. Of course, Peter. Yeah.
So, like, I think in general, I tend to have an automatic sort of suspicion when people state things strongly, as they have done with things like stored procedures. I think that very often criticism of things comes from fashion more than a deep understanding of the semantic pros and cons that a thing offers. And I think that you can do good programming with PHP, or you can do shitty programming with Clojure. And I think that you can make stored procedures work, and I think you can make them dreadful. It depends on the context. It depends what your objectives are. Depends what the economic factors are and the constraints. Like I say, Redis is dear to my heart because it's so transparently what it is, right? Like in some cases, it's absolutely not a good fit, but you're relatively transparent to know what the cases are where it's a good fit, because it just gives you exactly what it says it's going to give you. And I think that when it makes sense, I think it's a very good fit. But I think that it's sort of a deep question, or a deeper question maybe we don't have time for right now, but it's certainly an interesting one, is how one actually evaluates in general what kinds of ideas make sense logically, right? Like something conceptually like a stored procedure, what actually the pros and cons of that from like a conceptual semantics point of view. And I think that these are actually really interesting questions that sometimes get skimmed over because people have a knee-jerk reaction to say, I read that article that said that it's bad, or I read that article that said microservices is good, so we should use microservices.
Well, I think we've got 5 more minutes. I mean, we're maybe going to spend an hour on it, but I think let's not stop there. I mean, because I think one of the reasons why people were okay, I'll just kind of give you the I mean, I'm sure you're aware of them, but I'll give you kind of like for everyone that isn't, I'll give a quick rundown of some of the negatives of stored procedures. And the typical reasons behind stored procedures negativity is there's some sort of limit on the language. In other words, there's some DSL by a database vendor, and people didn't like that for whatever reason. So the limitations of expressivity and stuff like that. Like you say, there can be still good reasons to choose that. The bigger reason probably is the lack of transparency in the tooling and all those kind of things, where you have to buy into the tooling of a particular vendor to get the advantages, or to have visibility on the processing of a particular stored procedure. And then, of course, you're getting a lock-in aspect, but let's ignore that because that's obvious. So I think those are the two big things: expressivity and kind of like lack of visibility.
So those are obviously very important things, and I can't say that they're. How do I put this? So I think that the important thing in general when evaluating any particular thing is trying to understand what are the actual constraints of the particular problem that you're working with, and what are the hard parts, right? So it happens, for example, sometimes that you would hypothetically acknowledge, let's say, that the expressivity of the language that you're being offered inside your database is not particularly powerful, or it might happen that there's vendor lock-in, or it might happen that there's other, I think, valid criticisms also for stored procedures that one could level. And ultimately, it's up to the people involved, right, engineers and business, both to try to figure out actually what are the pros and cons that we get from this in this particular case, and what actually makes sense. Because sometimes it will happen that you say, look, these are particular kinds of debt, let's say, that we don't want to take on, or it's something actually where the overall set of trade-offs is positive compared to other reasonable alternatives that are available at the moment. And again, just giving sort of some anecdotes. So definitely Redis scripting, you have some of these same kinds of problems. For example, if you're writing your script now in Lua, right? We're choosing to use Clojure, not Lua. Clojure is more expressive. Clojure is more powerful. Also, let's say you've got some issues of let's say, your tooling, like you were saying, right? You've got this code, and where is it being set up? What kinds of tools do you have available for testing and debugging, things like this? So all of these are costs. The question is, what are you getting in exchange for it, and whether that is worth paying or not, again, is purely a function of what are the bottlenecks in your case and what are the viable alternatives. So I've seen cases where someone was using Redis and they were implementing a lot of important logic in the application, but because the application was distributed and so closure applications, because the application was distributed, trying to implement this logic on the client side, on the closure side, involved a significant amount of concurrency management, right? So it was figuring out sort of locking and distribution of information and timing things, and it was a reasonable solution, and it allowed, let's say, the bulk of the problem to be expressed in closure. But because of the location of where it's being expressed, right? In this case, in the client instead of the server, you sometimes incur other kinds of costs. For example, in this case, conceptual costs due to the fact that the distributed architecture, at least some parts of it now, need to be dealt with at the application layer, the client layer, where moving some of the stuff to a Lua script, even though the language wasn't as expressive and even though the tooling was not as nice, allowed, let's say, massively complex, like logically complex distributed code to be squashed into something that was actually relatively short and simple for Lua. And in that case, one of the, let's say, the economic constraints as well was the objective was performance. And switching from this kind of multi-back and forth solution with the distributed thing from clients coming from closure to something that could be done just on the server side, directly within the server, again, resulted in maybe an order of magnitude better performance. And ultimately, that's what the customer in that case cared about. And the complexity, let's say the other costs that were incurred happily. So I think it's always a matter of trade-offs and what you're actually trying to achieve. I don't think that there's a right or wrong solution. I think it's very much a case of what are the actual objectives and what are the viable alternatives. But in general, I think that it's an interesting option to have, right? The concept of being able to run things on the DB at the server side, I think certainly opens the door for some kind of interesting options. And like I say, sometimes it's a dreadful idea, but it's one of the things that I like about Redis, that it gives you that option, and in a particularly nice way against a particularly powerful set of basic primitives. In this case, it's basic data structures. I think it's a good fit because there's a lot that you can do with these data structures.
By the way, do you use Redis like just like a memcached sort of replacement, or do you actually use it like a full-fledged database where, I don't know, store it to the disk when shit hits the ceiling, sort of thing?
Yeah. So primarily the first case is usually what's recommended. So as some sort of temporary thing, just because the defaults are, so again, the design of Redis is very specific, acknowledging that there's different trade-offs to be made in the ways that we write software. And Redis more or less has taken a clear direction, which is to generally de-emphasize things like the persistence, the reliability, right? You wouldn't put very valuable data in Redis usually, unless you've got it very specifically configured, because the defaults, let's say, are not slanted toward giving you very high reliability in sort of the database sense. However, again, it depends on your use case. I think that saying that you shouldn't use Redis ever as a primary data store, I think, is just as silly as saying anything else without condition, right? It depends very much on the circumstances. And I've seen plenty of cases where, again, there were projects I was involved with, where the constraints were things like time to market or cost or performance, and the data was not valuable. And the thing is, if you have data, I don't know, from your kitten photo application that's going back and forth, and you need it to be really fast because tons of people are using it. But if you lose information on 10 kittens, it's not the end of the world. Something like Redis as a primary data store can actually work. You just need to understand exactly what the trade-offs are, what semantics you need, and how are you trying to mitigate some of the downsides, right? Because you need to be very clear on exactly what are the risks to your data, at what time do you incur those risks, and more or less what are your options for trying to mitigate them, assuming you need to. So it very much depends. But I wouldn't rule it out. wouldn't rule it out.
Of course. Okay. So I think we should, before we turn this into Redis podcast, you should really go into one of these MongoDB podcasts and then talk about Redis.
I've used MongoDB before.
So let's talk about the one of the biggest libraries that you released, Sente, or Cent. I don't know how you pronounce it. Can you give us some idea about what that library is about, and its use case and how you built it?
Yep. So for folks that aren't aware, Sente is basically just so I kind of describe it as a real-time. How do I describe it? Real-time communications, web communications for Clojure and ClojureScript. So essentially, it's WebSockets client server for Clojure that falls back to Ajax. And has a number of other, let's say, quality of life things that I found useful in real production applications. So, for example, these days I had a question, an interview with someone just the other day, and the question came up: why would you use something like Sente today instead of just working directly at WebSockets? And the honest answer is, so when I wrote Sente, at that time I had a product that I was working on where I had measured that a significant portion of my user base was not WebSocket ready, right? At least not practically, through proxies or whatever. There were issues and WebSockets weren't available. So in my case, it made sense to spend some effort to make sure that I could support those people in a graceful way. Now, is that still the case today? Probably not, right? The number of people who are not successfully able to use WebSockets at all is probably certainly decreasing number at the moment. But some of the reasons why something like Sente might still be interesting anyways, because there's more to actually building a successful production, let's say, real-time communication system, client server, than just, let's say, the underlying protocol for sending the message over WebSockets or whatever. There's a bunch of other little things. Sometimes it's things like timeouts. It's things like your general API. It's things like keep alive. It's unsexy stuff. That sometimes these things are important, right? If somebody's driving through a tunnel and they lose a message, what happens with that message? Or what happens if I'm sending an important message and it's big and whatever. So there's all kinds of things that you can already do at a library site to try and, let's say, maximize the use of bandwidth, which can sometimes be important on mobile by sort of packing things together or doing things in such a way where I'm going to retry certain things in certain cases when it's logically sensible to do so. So basically, it gave me a layer to operate one higher than sort of the web protocol layer, but just to say I have actual applications that I want to build, and for these applications, I would like to be thinking at the application level, because it's already hard enough to build a real-time application even using something like Sente. There's a lot of things you have to kind of be aware of, and you definitely have to design for it at the application level. So it kind of forces a shape on your application a little bit, sort of the notion that you're going to be working with this real-time stuff. But I wanted to minimize the amount that intrusion into the application space happened. And so doing something like Sente allowed me to kind of capture some of the complexity, let's say at a middle layer, which was a little bit higher than the protocol, but a little bit below the application, and say a lot of the stuff between applications is kind of similar. And again, a lot of the work that I've done is like prototyping a lot of different applications or doing like lots of different, especially web applications for clients, and having just a reasonable default platform on which I could build a wide range of different applications was useful. So that's why I built Sente, and then at some point I just released it because I figured it might be useful for others. Does that answer the question?
Yeah, of course. So it's basically sort of a middleware, right? Because it's not forcing anything onto the front end for you. It's not forcing anything onto the back end for you, like forcing you to use Ring or whatever, or any specific kind of thing, right?
Good question. Now, actually, funny enough, I haven't looked at Sente in long enough that I can't even tell you whether there's officially a requirement in Ring or not. I don't recall. You would need to check the documentation.
Okay.
But certainly it may.
There is a requirement, yeah.
There you go. Ray knows.
But you do support various web servers, so that's good.
Like HTTP Kit or
because Yeah, go on.
Yeah. So I'm guessing it's probably, if I recall correctly, it would probably be something like a ring compatible web server, and then there's a protocol that servers can implement to kind of plug into that. And in that case, let's say maybe that could even be abstracted away so that it's not dependent on ring exactly. But I think in closure anyway, that the ship has sailed, ring is more or less one. I'm not sure if there's any really viable widely deployed alternatives to at the ring level. So again, it's just in my case, it wasn't worth time exploring because I didn't care. But if somebody else is interested in that theoretically, maybe it's something that could be explored. I can't think of any logical reason why it wouldn't be possible to work on something else. But yeah, sorry, what was the question?
And one for the front end as well, because we were talking about, is there any specific dependencies that
So so it may force certain shapes on you a little bit. I can't think of anything too concrete. I mean, in terms of the API, as far as any API forces anything on you, right? If you're going to be using this as a core part of your application, and usually something like Sente is used as a core part of the application, then you will find yourself naturally conforming a little bit to the API to the shape that the API is kind of encouraging you to take on. Like I say, more importantly, the thing that often bites people is the stuff that's not immediately apparent. So again, if you're building a real-time web application, you need to be designing it for that purpose in mind, and you need to be thinking from day one, or at least thinking very logically at some point about what are the different things that can happen in a real-time web application in terms of your state and in terms of the business logic or the behavior of your application. And that's actually kind of a hard problem. I mean, it's not classically hard, but it's something that a lot of people aren't familiar with. And if it's your first real-time web application or real-time application where kind of messages are going like this, and there's often a UI involved, let's say, it requires some deliberate thought, because there's some decisions that you're going to have to make as an application developer that the library can't make for you, because it's going to be entirely application dependent, and you need to be aware that messages can arrive out of order. They can arrive, sometimes this one will arrive and then it won't arrive, and then message 3 out of a sequence of 5 will arrive because somebody was driving through a tunnel, or their Wi-Fi was bad, or they switched there's all of these different kinds of things, and you need to make sure, depending on your particular application, that you've more or less thought through the semantics of what it means to be doing real-time message processing in your particular application. And for some applications, it's pretty simple. For some applications, it looks deceptively simple, and then it ends up actually being quite complicated to make sure that you've kind of caught all the edge cases. But it depends as well what the risk factors are, right? Like if it's just an online game or something where it doesn't matter, then maybe some sort of semantic breakage is not that big of a deal. If it's something where you're dealing with important information and important decisions are being made based off of this comms infrastructure, then you need to have your semantics right.
I think what's interesting, because I mentioned to you before that I'm using Sente for this this distributed shared REPL that I'm building. Is that in terms of API, the API is quite small. In fact, there isn't really an API as far as I'm concerned, because you just plug things in, and then you have some kind of like model multi-methods. And then you write your own, you as a library, as a tool author or as an application developer, you basically write your own multi-methods on either side of the socket connection and just route your data that way. So it seems to be almost more about like the data design in that respect. At least that's how it feels to me, that it's more about like the data that's going over the wire and coming back. Than following a particular API that you've imposed on us, which I really like, by the way, because I think that's using the power of, it's not constraining me to say, okay, you must use these sockets in a certain way, you must get your data like this, you must get your data like that. No, I write the API essentially.
Yep. So I think that was a nice observation about it being mostly data centric. And let's say I think that the API is, what there is of it is there to kind of support the conveyance of data in a way that's useful. Like I say, the particular application design that you ultimately end up having or needing or wanting for a real-time web comms, that's something that you would need to think about from an application to application basis, and it may have interactions with how the Sente API works. So the API, as small as it is, let's say it gives you certain basic things like I'm going to send this and not care about the result, or I'm going to send this and I want to look at the result and there's a timeout. And so it's very basic building blocks that it gives you. Yeah. And the intention is that these building blocks kind of pave over the differences between the particular protocols, so in this case Ajax and WebSockets. But I guess it's a little bit subjective to say, is that forcing much of a shape on you or not? I guess that's sort of debatable. Some of the aspects like how identification, user identification work, and things like how the keys work for identifying messages back and forth. You may find cases where, let's say, Sente can be a little bit opinionated. And for example, I've had cases before where people wanted to use it in applications where they wanted the user ID to be based off of something that didn't particularly fit well with the model that Sente was originally designed to support. And there can be times where you will sort of butt heads with it a little bit because it's fundamentally going up against the direction of the kinds of applications that I was intending to build with Sente. It can happen. So you won't encounter it, let's say, on the basic stuff of, this is the send API, but you may encounter it in deeper ways of how things like identity work and how the application in general should be structured in order to make, like I say, sort of a conceptually sound real-time application. So there may be pushing from the library to conform to a certain kind of shape, but in my case, I would argue that most of that pushing is actually healthy, because most of the time when that pushing isn't happening, people haven't even realized they need to be in a particular shape, because it's not apparent at that point that there's a reason to really have a serious think about adopting a shape of some kind or another to deal with things like identity. Because again, sometimes these things, when you get started, they seem kind of simple, but when you actually dig into the details and you dig into the nuances of like how browsers actually communicate state and how it works with tabs and different devices and things like this, occasionally it will encourage you to go down a certain road, and it will sort of provide a specific path that offers least resistance. If that kind of made sense. It was a bit of a rambling answer.
No.
I fell asleep. Sorry, what were you saying?
Sente is great. Use Sente.
Use Sente, yeah. No, you're right. I mean, I know the whole business about authentication and logging in and all that kind of stuff. I see on the chat that there's a little bit of contention there, let's say. But yeah, I mean, you're going to inevitably, and what you do, and it's interesting to me the way you've done it is you've essentially said, look, you can log in via Ring or you can log in via WebSockets, and then if it's WebSockets, you're on your own, make it up using this sort of technique, and if you're using Ring, then it's just a standard middleware. And that was the only thing that I thought was a bit odd, was like you essentially hide some of the data under some atoms that are only read-only, so like user membership and stuff like that. That's the only thing. It was. I think in the end you're right. It was just something which I hadn't expected, that there was sort of hidden behind the API, that it was some data structure that you took care of and I couldn't have an input on.
Yeah. So this is the biggest source of contention with Sente, and I would say that it's one of the bifurcation points. Where you would ideally decide whether you use something like Sente or not, because again, Sente took a very particular direction to solve particular kinds of problems, and by making certain assumptions, it could make lots of simplifications, or at least provide lots of support in direction A. But that direction is inherently in opposition to some of the other kinds of applications you may want to build in direction B, and for things like, for example, a request that I get quite often is, I would like to be able to send a message to a specific client ID, not to a user, but to a client, right? And there's long posts on GitHub about sort of what the pros and cons of that are, and why the library has more or less rejected the notion of being able to do that at the client ID level. And I understand that might be frustrating, because sometimes people want to kind of send to a client. But in general, again, it's been my experience that when I've seen these things in the wild, 9 times out of 10, the desire to want to go in that direction is an indication that you haven't properly thought out how this is actually going to work properly, and you're going to end up regretting this decision at some point. So I would normally try reverse the kind of mental model and say, look, if you've got something where you want to have a particular response to a particular client, try to initiate the request from the client, because that way you can use the basic API and get all the sort of anyway. It's a bit of a long story, but suffice it to say, there is certainly a different design choice that could have been made there, and that might make sense in certain applications. But at least in my experience, I'm not convinced that I've ever actually seen a use case where I've been fully convinced had a strong argument for wanting to go this direction, or the opposing direction. Every use case I've seen where people had the inclination to want to go this way, on sitting down with them and actually working through the design, we both concluded afterwards that the direction that it kind of encourages you to go actually made more sense. It just required a bit of a mental rework of the situation. But it could totally happen. I can't exclude the possibility that there may exist some application that would actually be better fit for, let's say, sending something to the client ID level. And if that comes, and if somebody can suggest that, then we could maybe open up the API to do that. Or indeed, I think you could have another library do that. I think that it's important that people use something that kind of fits their particular use case.
I mean, I think an example of that for me was where I'm evaluating something in my REPL locally, but I want other people to be aware of it. So I send it over the network to be evaluated, and then the server side evaluates it, and it basically broadcasts the results. And in theory, it could broadcast it to the other clients and not to me. But actually, in practice, what I did is I just ignore it. If I know I'm the producer of that message, I can just drop it because I've already got it. So that turned out to be a much simpler solution, in fact, where I can just say, okay, I'm initiating the action, and everyone gets the result. And then if you're not interested in it, you just drop it.
Yep.
And that turned out to be a much simpler model. And I guess that's probably where you're coming from as well.
This is a good example, and there's trade-offs. As in the example you mentioned, obviously one of the disadvantages is that you're now broadcasting to clients maybe that are intending to drop it, right? So you're wasting bandwidth, you're wasting time.
But I know it's only one. I know it's only one, or out of 4 or out of 400, it's only one that's going to drop it. So
okay. Okay. Yeah. So in that case, it sounds like that's a pretty close, pretty accurate example of what I had in mind. Yeah.
Yeah. I mean, if you're going to send it out and then half of the population is going to drop it, then it's a bit more tricky. But then I think the other problem is that how do you register your interest? Then you're putting some filter on the server side. Then stored procedure styly, it all gets a bit funky. Yeah, like you say, it's a general purpose library.
Yeah. So the honest answer is I actually don't even recall exactly what some of the design trade-offs were from this thing, because it's been a long time since I've looked at that, and I deal with so many different things. I couldn't even remember whether ring was a requirement for the library. So normally what happens with these cases is if it comes up that it's somehow relevant, I'll kind of look at the issue again. I'll refresh my memory of sort of what all the trade-offs are and what the reasons were. I don't have it cached at the moment. But certainly I remember having had this experience before with clients where there was a feeling to want to kind of go in a particular direction, and I've gone through it several times where when we actually evaluated what the semantics were, we always found edge cases where there were problems in going in the direction that seemed attractive on the surface. And ultimately we decided to go with something simpler, which was kind of what Sente was encouraging. But again, I absolutely don't exclude the possibility that there may be some case where that won't make sense, where some other approach would be preferable. I don't have enough of the details in my head at the moment to sort of clearly talk about what I anticipate those cases might be, or what the trade-offs would actually be. I need to look at it.
I think what's nice about it, though, from my perspective, to get back to the sort of concrete positives, is that you can choose the data structures in a way that's very nice for closure. You can put like Eden or transit on a wire. It's very easy to parse that data. Then it's easy to sort of, from an API perspective, I'm kind of I kind of spent a long time, like you were saying before, about kind of like absolutes. People went SOAP for a few years, and then it's terrible, and then it went REST, and now because Netscape and Netflix and Facebook don't like
Netscape.
Netscape. I was there for a while.
Mhm.
But when Netflix and Facebook said that REST was terrible, everyone yes, GraphQL, that's what we need to do. So but what's interesting, I did REST for a long time. I didn't do much stuff with WebSockets before. So this is my first big WebSocket application. Big, not very big, but first proper investigation into that rather than a theory. And I'm finding WebSockets a real pleasure to use actually with this tech. I think if you're doing kind of bits manipulation, if it's all binary stuff, I imagine WebSockets are horrible. But using it with Sente over Clojure, it's so easy. It's so much actually nicer than a REST API because you're just talking, message passing, which is really nice. I'm not talking about RPC here. Just here's some data, do with it what you want. Yeah, and then on a reframe side, you just look at the data and say, okay, that's this type of data, that's that type of data. Put it in the database, trigger some event, and the UI does something magical, and it's all good.
Yeah, so it has been a big pleasure, and I've used it a lot for. Again, a lot of work I do is prototyping applications, and it's been a joy for that because you can get started so quickly, and like you say, it's a good fit for things like React, reagent, whatever particular library you're using. You're just passing data back and forth like this, and it's for me, it's been a source of significant productivity for some real applications to be able to do message passing like this. I found it quite enjoyable.
Okay, so I think we can talk about one more library. I know I said 3, but obviously, there are plenty of
bonus
things.
One more library, one more thing.
Just one more thing.
Yeah,
one more thing.
We're gonna have to have another show in a year or
of
so.
Course.
Secret
when everyone's
announcement.
recovered.
Yeah.
Because I'm really curious about your goals for Truss. Because it seems like a kind of sort of spec, but not really. But so what is it, and what is the idea behind it, and where are you taking this one to?
Okay, so Truss I actually think is probably my most interesting library, and I think it's a bit of a strange one because I think in some ways it's one of my favorites. But it's not very well known, and it's not very widely used, and it came along at a bit of a strange time. At least it was published at a bit of a strange time. So Truss, for anyone who doesn't know, is I kind of describe it as basically an invariance library for Clojure. And what I mean by that is essentially it's a way of making assertions in your code base about invariance in your system, in your code at that point in time. Like you mentioned, there's some, let's say, functionality overlap with things like Clojure.spec and schema. So it was a quick history. So I mentioned before that I started using Clojure way back when, like already version, I think 0.9, something like that. That I already had at that point like a large production application going. And we were talking earlier about things that we like or dislike about various tools. One of the things that I found at that time challenging about Clojure was the dynamic typing. And in general, I actually tend to have a preference towards strong static typing in general. Again, there's trade-offs, and I think if you kind of use them with your eyes open, Clojure gives you a lot of leverage to, let's say, minimize the pain from this. But anyway, I had some production applications where the dynamic typing in Clojure was really hurting me on an ongoing basis. It was causing problems. It was causing lost productivity. And I noticed that when I was consulting, it was occurring very often as well in the wild. So the same kinds of problems that I was running in with my larger applications, I was observing a lot in client applications in places where I'd kind of been called in to help with the code base or struggling project of some kind. And it basically boiled down to a lack of a lack of ability to convey semantically some of the invariants that we have in our system. So like a type system is one obvious way of doing this in one way, to say, okay, this argument is an integer, the return type is a whatever. In practice, what I noticed with Clojure was most people didn't experience this pain because most people were running small projects, right? If you have 1,000 lines of code or 4,000 lines of code, the dynamic typing doesn't bother you at all. It's fine. You don't even notice it because the program is so small. You have the whole thing in your head. And especially if you're writing Clojure in I don't want to say exactly in the idiomatic way, but in a way that Clojure encourages you to write, where you tend to have nicely decoupled systems and so on, you can actually get pretty far in building real large Clojure applications while being able to retain the whole thing at your head, the whole thing in your head. Because even if there's lots of concepts, the way that they kind of compose is nice and clear, so it's easy to stick a lot in there. But ultimately, every Clojure project, I think, that gets big enough at some point becomes large enough that there's part of the code that like you haven't seen in 6 months or a year, and it's complex. And in particular, when you have applications which have complex business logic, so like a lot of applications which I was working on, which were highly mathematical, which were dealing with a lot of like complicated algorithmic stuff, it becomes really, really difficult to keep track, right? I'm making the refactoring of this thing over here, and I think that I recall that this, or it's covered in the unit test, sort of, but it wasn't exactly completely specific. Or, I mean, famously, one of the things that Clojure is a bit of a sore spot for people is its error messages, right? And this comes, again, everything pros and cons, being on the
Don't
JVM.
mention the error messages.
But being on the JVM is wonderful and a wonderful source of productivity and leverage. But, you know, the fact that Clojure is also implemented on all this book underneath makes the error messages, I mean, I'm not sure if that's the only reason, but certainly that's one of the reasons why the error messages can be so opaque. And one of the things that I noticed was on my own project, and then also in the consulting, was when there's errors in production in Clojure, sometimes they are so maddeningly difficult to debug because you get some funny stack trace in some little function in the middle of nowhere, and it says it's a null pointer exception, or it says there's some whatever ridiculous stack trace that, again, very often at the times when you're supposed to be debugging these things, money is being burnt and there's urgency to try to get a solution. And it's incredibly frustrating when the amount of information you get out of the system is so small and or so unhelpful. Anyway, so at that time already, this is way back when, this is before schema, this is before anything else, I wrote a little library, so at the time just a set of utilities, which I started using for myself to cover two use cases. Number one, refactoring, and number two, basically this case I described with like issues in production. So when you're writing some code, what I found was, particularly for large code, while you have it in your head and it's clear, in particular, it's clear how different pieces connect, you have certain understanding of how, let's say, assumptions which are implicit to you at the time that you're writing the code, but aren't explicit in the code, either because they're minor and they're not a part of the public API, or it's something within a function, or it's something about how this component relates to that component. And trying to keep this stuff documented and trying to keep it all sort of in a way, let's say, covered by the unit tests or something else which is actually reified in the code, so that it's under revision control and it's there as part of the contract of the code, is tricky. And like I explained, I've got a video on the trust library where I kind of go into some examples of where this comes up. But essentially, your choices are things like docstrings, or it's something like core.typed, or Clojure.spec didn't exist at the time. But basically, there were various tools for doing this. And for me, none of them kind of felt immediate enough. Meaning, I'm typing some code, and in my head, at the time that I'm typing the code, I have some particular invariant in mind. I know, for example, that as a trivial example, this is going to be a vector, or more interestingly, let's say the state is in a particular position. So if we're talking about like real-time web communications, these are the kinds of like edge cases. I'm getting message X, and my expectation is at the time that I've gotten message X, either condition A or condition B are holding, or something about the user state, or something about the connection state, or something about how these components relate. Again, it's a bit difficult to give examples in abstract, right?
So obviously, Clojure had preconditions for a long time. So what kind of what didn't you like about that?
Awesome question. Okay, So Clojure had preconditions, and it also has assertions. You can just do assert on any particular state. So there's a few things I dislike about both of those. Number one is that the error messages are useless. So if I have a function and I say the precondition is
just tell it how it is, okay?
Yeah, but I mean, it is the case. Preconditions
yeah.
don't solve this problem. Preconditions give you the ability to throw an error that's just as useless as the other errors that you would get, right? It will throw something like, let's say, function over here was expecting a vector, but it actually got a set. Excuse me. You'll have a precondition like the input to this function is a vector, and it will say, okay, that didn't happen. The precondition failed. At that point, you've got no other information. You don't understand why it failed. You don't understand what the input was to the function. You don't even know what the data type was that wasn't a set, or that wasn't a vector, right? So we're expecting it to be a vector. That wasn't the case. It threw an error, but you've got no other information to work off of. And again, if that happens in production, or even if that happens in development in a large complex program, you're going to end up spending a bunch of time trying to track down. Yes, the precondition has helped enforce an invariant, but it hasn't helped you when that invariant is actually violated. It hasn't helped you very much actually debug or understand what was the state of the program that caused this particular invariant to be violated. So it will say, wasn't a vector. Cool. But now, if that happens in production in a function, and you're looking at the function and you're looking at the consumers, and it looks like all the consumers are being called with a vector, how is this happening? Clearly, there's some sort of an edge case happening somewhere that somebody's calling it as something that's not a vector. But is it nil? Is it a set? Is it a string? That would be helpful to debug, because if you know what is the invalid value that's getting into this thing, it gives you an enormous amount of context to try and guess where is it actually coming into the system. When you know that the invariant's failing, but you don't know how or why, it's again, when you're lucky, maybe you might have a hunch. When you're not lucky, or when you're under time pressure, and in particular when it's a large program, it's not very useful. So one of the primary motivations behind Trust was just to fix this particular issue. And theoretically, this could be fixed in Clojure core, actually. There's no reason this couldn't already be done, which is when there's an in violation, provide as much contextual information as possible, right? Provide line numbers, namespace, provide the forms that are going in, provide the values that are going in. So if, for example, I'm doing an invariant to say this value is a vector, right? And it triggers a warning, it triggers an error in Trust. Trust will tell you, no, this failed. It will show you the actual predicate function that failed. It will show you the input. It will show you the data type of the input, and it will allow you to attach any arbitrary context to that error message. So it gives you a lot of information in the error. And again, this is not sexy stuff. It's not that complicated. It's just attaching a little bit more information. But even basic stuff, like just what was the value that didn't satisfy the condition, is just massive time waste when you don't have that. So providing this information just to things like, let's say, improving the preconditions or improving the postconditions was already useful. But more importantly, or let's say to kind of generalize this notion, preconditions and postconditions are about the public API of functions, right? So it's about what's coming in and what's going out, and that stuff is of course very, very important. And arguably, it's sort of the most important thing. But as a programmer, again, when your programs get really bigger and bigger, especially ones that are logically complex, there are more invariants that you have in mind than the particular API contract of functions, right? Within the function body of a particular thing, you may, within the function body, be making certain assumptions, either about the state of the world or about different systems, or even about the flow of the particular program. For example, right, you're working with something and you've got a left binding, and over here you're pulling something out of a set, and 3 lines later, while you're writing the program, you know that there's no way that this value can be nil, right? Because you know logically you just put it in over there 2 lines earlier. So between here and here, like if you look at these 10 lines of code, there's no way that this value over here can be nil. Cool. But the thing is, now you save this code and it goes into production, and 6 months later, somebody else is working on this code and they're refactoring it. And because you're working in, it's not uncommon, some sort of a situation where, let's say, the features are changing very often, you've got a prototype and stuff is quite dynamic. Again, it's one of the benefits of Clojure is that the dynamic language allows you to kind of play with your ideas over time. So inevitably you do that. And somebody is refactoring this function or changing this function, and they skim this thing, or they're reading it and they miss the fact that actually this is supposed to be this can't be nil at this point. And they end up passing it to another function where that's a problem. Basically, when you first wrote the function, you had an implicit assumption of some kind in your head that you thought was self-evident while you were looking at the code. that some time passes, something changes, and somebody else is looking at the code, they refactor it, and since it wasn't explicitly documented that there's this particular invariant on the value, somebody maybe makes a change now, which seems to work 90% of the time, but has introduced a possible edge case to something, because now when these three conditions hold some weird case that isn't covered by the unit test, there's now a nil value in here, which gets passed to a system, which throws an exception, which says null pointer exception with no other information. So anyway, what Truff allows you to do, and again, just purely dog fooding here with solving issues that I was having and that clients were having, I found it massively valuable to just be able to assert inline and say, I'm asserting inline at this particular point that this form is going to be non-nil, or I'm asserting that this particular form is a vector, or I'm asserting that this particular value is bigger than that particular value, or whatever, right? And again, it's a bit difficult to give realistic examples in abstract, because the place where I find this useful is in real applications, right? Where you have actual significant business logic of some kind. And that doesn't convey well to kind of toy examples. It's a little bit difficult to articulate. Like, a lot of people might hear this and think, I don't have a need for that. I've never seen a need for something like this. And that would be completely true, because they might not have had these kinds of situations where you have substantial business logic inside the functions. But when you do, I found it invaluable to be able to make assertions on the state of your program as it's running inside at any particular point. So Truss will always return, when the invariant passes, it will return the inputs that you put in. So if you say this is a string and it's true, it flows through and it gives you the string. So you can kind of just insert these things in line. And what I noticed is, since I started doing that in my own programs and in client applications, our error rates dropped substantially down, and our time spent maintaining and debugging stuff actually went substantially down. Just this one small thing in a few little places here and there, because I noticed how much, like disproportionately, how much time debugging was actually spent on these just stupid things. Like, sometimes something could have just been codified as part of the code, some sort of an invariant. And if it's violated, just provide a really good error message with as much context as possible. That stuff sounds stupid. It's not sexy, but it saves enormous amounts of time, at least in my experience. And so this was way back when I started using this. Then after that, at some point, schema came along, and people were using schema. I never published the early version of Truss, and people were using schema and finding use in schema. Then obviously now closure.spec has come out, and I think that's also really interesting. And I think in general, I would sort of encourage people to look in that direction. It's not entirely obvious to me yet that closure.spec has completely obviated the need, at least for me, or the value of something like Truss. I still tend to use Truss myself. I use it for different reasons, right? Like, spec I find really good for defining like data structures and API level contracts, and in particular, I love I really appreciate the fact that you kind of get to leverage the syntax to do several things, including things like the generating and the doc strings. And it's wonderful leverage, and I think it was a really good design and a good idea for a core language thing. Like, if you were going to design something like this for the core of the language, I think it was very nicely done, and it offers a really, really good balance of functionality for the cost, as it were. But so still, the error messages are not ideal. I think this is something that can be fixed, but also people keep saying that it's going to get fixed, and ultimately needs to get fixed at some point. And also, I never found it quite as comfortable for me for inline assertions, which I find is still sort of a bit of a sweet spot for Truss. So like Truss has a bunch of little things for like destructuring. If you have several, for example, I'm going to say, I have these values and they're non-nil, and then you provide three or four different symbols, and if they all pass, it gives you back a thing in a vector, so you can just destructure them. So there's little syntactic things like this, which, again, syntax is not the most important thing in general. I rarely find it sort of an interesting argument to say, language X is better because the syntax is nice. Your syntax, doesn't really matter that much. But in this particular case, I actually find that syntax is important, because arguably people could just be documenting things, right? And they could just be putting comments in their code. but the trouble with comments is, because it's a comment, it's not being run by the compiler. It's not being checked. It tends to go stale. People forget to update it. People are also lazy about it. So what I found very useful with the trust syntax was it was terse enough and expressive enough that, in my experience, people would actually use it. And I used it, and people that I worked with actually used it, and they enjoyed using it, and they found, I guess they found that the overall net expense of annotating a couple forms here and there was more than easily paid for by the advantages, and so they were inclined to do it, and they did it happily, and it wasn't something that you kind of had to force on people. That's a really long answer, but
I think the nice thing about it, though, Peter, I mean, is that again, it's like conceptual overhead is quite small. You write have something, and then you're pretty much done. So you're not buying into a very big API and also like a really good DSL. It blends perfectly well in and composes well with all the other predicates, which is kind of the thing about spec as well, which is, that's one of the advantages of spec is you just use language predicates, and that's one of the advantages of truss as well. So, you saw that, and I think that's really a great insight. Because doing something where, you have to essentially replicate all of the core predicates like core type did, then you're kind of, you're on a losing horse, I think, because it's a different language at that point. Whereas what you're doing is you're just saying, okay, well, there's just one very small thing that can help you to assert stuff, and here it is, which I think is really... I agree. I mean, I think it's a really nice, useful library with a very low conceptual overhead, but quite a lot of payback. Maybe it's not as much leverage as spec, but then the overhead for using it is also incredibly low.
Yeah. So in general, you'll notice a theme in a lot of my thinking and a lot of my libraries as well, which is just I tend to approach things certainly with the published open source just from a practical point of view, right? Because in general, my interest is not actually in the programming. My interest isn't in making nice tools or hacking on this stuff because I find it enjoyable. I do find it enjoyable, but ultimately I do stuff because I have a project that I want to build, or I'm trying to get something else done as quickly as possible. And the way that I can get back to that product as quickly as possible is kind of my motivation. So for a lot of these things, like with Trust, I found a solution that worked for me, that fits, that let me decrease the time spent in maintenance and the time spent in debugging. And what I can say is ultimately, in my case, purely subjectively, but after using something like Trust and kind of getting the grips of where, sort of developing an aesthetic for where to use it, the problems that I had with Clojure being dynamically typed completely went away. I no longer miss my static typing from Clojure. And in fact, I actually now feel pretty satisfied at the overall balance that I get between the dynamic typing and the ability to express invariants. And in particular, I like the fact that invariants are in general are a more general concept than just typing, right? Because typing, again, the easiest examples to sort of share are typing, to say this is a vector, this is a string. But those aren't actually the most interesting things, I think, in practice. The kinds of invariants that I find useful in production are, again, business logic things. And again, providing information to say, all right, this statistical function, whatever, this is supposed to be bigger than this under these, and expressing that as an invariant, and then attaching debug information for when that invariant doesn't hold. It's just, I really cannot overstate how much time this has saved me. It's saved so much time to be able to do this. And again, I often haven't needed it in many places, but in the few places where it's valuable, the value is just outstanding.
And composing predicates like this is so easy compared to, the higher kind of typing system that you would need to do a similar thing in a more, a more type-oriented language. You can just express a bunch of predicates in not even one line. Well, it is a line, but it's it's a short line. It's really nice.
Best thing with this one is that you can just use as much as you want. It's not forcing the entire program to be following certain design or following certain types. So you can just put in, okay, here this is the most critical part of my code, so I'm going to put in something here that is going to get maximum value out of that one, instead of doing a large upfront design.
Yeah, and obviously the thing is you can have spec and you can have trust. The two things are not incompatible. In fact, they're completely composable. They're completely what's the phrase?
Orthogonal.
They can coexist happily. Yeah.
And to be clear, absolutely. I think that you trust would be a terrible spec. Trust doesn't do what spec does. If you're talking about like data structures and things like this, spec is great, and you wouldn't use trust for that.
No.
So I think actually for me, one of the nice things, the release of spec helped clarify for me actually what are the boundaries of what I enjoy about trust, and where I guess it helped clarify the boundaries a little bit anyway for what I was actually looking for from it, because I noticed in myself where was I still reaching for it versus other tools. But ultimately, something that I really like about Clojure in general, like we were talking earlier on about, it's a list, that's cool, but the things about Clojure also extend a lot. There's more nuances about Clojure that I think make it really attractive. And one of the things that I really appreciate about Clojure in general is that it tends to be a craftsman's language, right? It's practical. It's mostly functional, but it doesn't force you to be functional in all cases. It's mostly immutable, but it acknowledges that sometimes you want to be able to mutate things. It strikes a practical balance, recognizing that people sometimes need to get stuff done, and we're just trying to achieve a mission here. And a way that I would put that is Jonathan Blow has a nice way of putting this, which is so he's developing a programming language at the moment, which is really, really interesting. And I'd encourage anyone who's interested in sort of low-level languages to check it out. Jonathan Blow is working on a language called Jai, J-A-I. The most interesting programming language project going on at the moment, in my opinion. Anyway, one of the things that he's doing with his language that I also appreciate is it's not a big ideas language, as he would put it, right? It's not trying to make it impossible to throw, to have a null pointer exception. It's not making it impossible because these super sophisticated type systems, right? Like I found it interesting when Rich released transducers and everybody was trying to sort of provide the type signature, right? For transducers. And like, I think that it's also possible to go too far. And again, this is purely subjective. I don't think there's a right or a wrong. It's a matter of taste and it's a matter of what you're trying to do. But for me, my particular taste is I'm interested in stuff that gets the job done. And for me, like a full-on type system would take away a lot of the joy that I feel in Clojure, and I think actually a lot of the benefit that I get from it is being a dynamically typed language, and I get a lot of leverage from the fact that it's dynamically typed. And again, it's for these reasons that I've done a lot of work in like prototyping in Clojure, because it's awesome. But then because also it's a list and you can write macros, you can plug on something like this where you get to do a little bit of just reinforcement at the edges that you care about when you need. And I find that's a really nice balance.
Okay, cool. I think we are, of course, I mean, there are lots of things to talk about, obviously, but, we should probably make it a two-parter at some point. We need to come back and then discuss most things. And I'm really curious about, this has been fantastic. I mean, we discussed a lot of things. So I think we can call it a wrap. Peter, thanks a lot for joining us and giving us your time and describing a lot of awesome things that you're working on. I learned shitload of things today, and of course I'll take a look at the Jai language as well. That's I've never heard of it, so I'm really curious about I'm trying to follow learn one new language every year sort of shit for some time. So my Rust is a bit rusty right now, so I'm on Rust now. So hopefully next year I'll pick up something else. But anyway, again, thanks a lot for all of all your time, and of course fantastic libraries. For the people who are listening out there, maybe you're already using his libraries, so go to his website and click on the back button, not the back button, but back me up button.
The back button. Don't use them. Don't use the library. Please don't be angry with me if they're not working correctly. I'm not responsible.
Go to his website and do not click the back button, but click back me up, or how do you call this in English? I mean,
Patreon.
Yeah, no, not Patreon.
The support me. Yes, become a backer.
Support me. Exactly. Become a backer of his amazing
or the back
amazing
button.
work.
Or the back button. That's fine too.
Exactly. So I think that's it from us today. Again, it was fantastic to have you online today.
Thank you very much, and thank you for being patient with my rambling, opinionated, nonsensical answers.
No.
No, we love it.
This is exactly why we do it.
Yeah.
Awesome. Thank you both.
So a quick shout out to the things.
The things.
Yes, the regular shit. I mean, this is the weird part. I mean, the thing that we do in every show, I keep forgetting what I'm supposed to do. All the music coming from Pizzery. He's PTZERY on SoundCloud. Go and like his music. I'm not sure if he's making any new tracks or anything, but keep listening. And all the hard work of making us sound better is being done by Wouter Dullert from Belgium. He's been doing awesome work and helping us a lot. And of course, we are also on Patreon. So if you want us to retire sooner and then buy our own yacht and shit and go there and give us your money, and then we'll put your name on our yacht.
Yeah, that would be good. Yeah.
Is that a promise?
I'm gonna put that on my sponsored by, or at least a paperboard at some point. That's it from us. This is episode number 36 with Peter Tosanis. Thanks a lot.
Thank you, Vijay. Thank you, Ray.
Absolute pleasure.